product and quotient rules.
This was one of the stickers?
Yes.
I didn't even see this sticker.
That's a sticker.
Oh.
All right, so product and quotient rules. Okay, so up till now, to like take the derivative of stuff that's been like multiplied together or divided, we've actually had to like multiply and divide it first, right?
Yeah.
Sometimes, I don't know about you, but that's kind of a pain in the butt, right?
Amen.
Okay, so we are going to learn about the product rule first, okay? So the product rule says that if a function of a product, if a function is the product of two differentiable functions. So if you have two things you can take the derivative of, multiply together, okay? Rather than actually having to multiply them together, okay? We can apply the power rule, which is the first function times the derivative of the second function plus the second function times the derivative of the first. Right? More quickly said, the first times the derivative of the second plus the second times the derivative of the first. You'll hear me say that a million times. Okay? It sounds like a lot, but it's actually not that bad. Let's do an example, okay? So like this first one, we have 2x minus 1 times x minus 4. So we could FOIL it and then do the power rule, or we can do the product rule, right? So we have our two functions. So like here's the first one, here's the second one. Okay, so this says, I don't like the way they do it. I do it backwards. It doesn't matter. So you take the first function as it is. Leave it there, okay? And then you multiply that one by the derivative of our next function. Okay, so what's the derivative of x? 1. What's the derivative of 4?
0.
Okay, and then you add the second function, which is x minus 4, times the derivative of the first function, the pink one. So what's the derivative of 2x? Yeah, it's 2. Okay, so then now we have 2x minus 1 plus 2x minus 8, so 4x minus 9 is our derivative.
Well, why?
That's the answer.
What's
Now-
the 1 and 2 again?
So those are the derivatives. You take the first part as it is, times the derivative of the second part. And then you add the second part as it is, times the derivative of the first part.
Okay.
Okay? So like again, for this one, I feel like FOILing would probably be faster. But like for things like this, like that multiplication takes forever, right? You got to do it. So this is where the product rule is going to be a little easier. Okay? So let's try this one. I'll keep color coding them the same. So we have our first and our second. Okay, so we take, again, the first one as it is. All right, and then times the derivative of the blue one, which would be what? 4x. All right, and then we add the second function as it is times the derivative of the first one, which is 2x plus 3. Okay, so then we simplify that, right? So for this first part, we're just going to distribute that 4x in. So 4x cubed plus 12x squared minus 4x. And then we do have to FOIL on this part. Right, so we get 4x cubed. Because the second half here is 2x squared minus 5 times 2x plus 3.
Oh, never mind. Yeah.
Okay. So then, 4x cubed, 6x squared, minus 10x, minus 15. Then just combine any like terms you have and you're done. So 8x cubed plus 18x squared minus 14x minus 15. You following? So the product rule is on that paper I gave you guys yesterday. Right, so it says like f prime times g plus f times g prime. That's what it means. Okay, so then let's do it with part C here, okay? So our first function is, let's see, 2 sine x.
Do we have to change it? Oh, we only have to change the second.
Right. So then, so the first is 2 sine x, right? Times the derivative of the second, which is negative sine x. Right, plus the second one as it is, times the derivative of the first one, which will be 2 cosine x. So since those are multiplied, right, I can rewrite that as negative 2 sine squared of x plus,
Will it usually change to a square thing?
if you're multiplying 2 of them together, yes. Oh, I forgot the 2. Plus 2 cosine squared of x. Yeah. So like cosine
Would it be like a cosine and a sine multiplied in the end after you do this?
could be, yeah.
Then
Like,
you just like cosine sine.
yep. Yeah, if they're the same, you can square them. If not, just leave it. Ready for another one? See, this isn't that bad, is it?
It's alright.
I feel like our volleyball people will be able to catch up quickly.
It depends what day they're having.
That's true. I have the faith. I'm also recording this for them, so.
They'll live. What's the worst that can happen?
All right, so first as it is, times the derivative of the second one, which is 3x squared, plus the second one as it is, times the derivative of the first one. So that would be 3e to the x, because that stays the same, minus 2x.
Whoa. Would just be 9ex squared?
So it would be 9e to the x, x squared,
Oh.
minus 3x to the fourth. Oh, see, this lady in here didn't even combine them. Well, you don't always have to. So first, outside, inside, last. So then you foiled outside. So then 9e to the x, x squared stays. And then I have 3e to the x, x cubed, minus 5x to the fourth, minus 3e to the x. I probably should have swapped those two, but it doesn't really matter. Dylan, you alright, bud? No, I'm sorry.
As much as I don't like to be in school, I hate being gone because that makes everything harder.
Yeah, no, I do. All right, so we feel good with the product rule?
Yep.
Okay, so now we're going to do the quotient rule. Okay, so this is when we have
What's low divided?
quotient. What?
Does it say low?
Low-de high.
What's low-de
high-de low.
What's D?
Oh, like derivative.
Ah.
Like, so low derivative of the high.
Low to low.
Yeah, so like that's the way people remember it, I guess.
I like this. We should make it like a song or something.
You get on that, musical Kate. Okay, so now we're worried about the top and the bottom. So quotient rule says you take the top, no, the bottom times the derivative of the top minus the top times the derivative of the bottom all over the denominator squared. Okay, so similar to the product rule, just a little more steps. Okay, so we take the bottom, which is x minus 5, times the derivative of the top, which is 3x squared plus 8x.
It'd be 6x squared.
Oh, yep. Sorry, I was thinking it was just x squared or x cubed, so I. And then we subtract the top.
Why is it 6 again?
Because 3 times 2, yeah. Times the derivative of the bottom, which is 1. And then all of that over the bottom squared. So typically for these, I wouldn't even bother like actually squaring out the bottom. Like I'm perfectly fine if you leave it as like x minus 5 in parentheses squared. Now I would on the top multiply through and FOIL, like just so you can combine any like terms you have and kind of shrink it down. What?
The bottom, if you
Well, no, not the derivative of it. Like actually squaring it. Like this is the derivative.
Oh.
Like this is g prime of x. We've already done that part. Now we're just simplifying.
So you have to like factor.
So we already counted the derivative, we just gotta make it.
Yeah, now we just want to simplify it so it's easier to read. Yeah, so like on the top, yes. On the bottom, you can leave it.
So don't do like x squared minus whatever.
I wouldn't, yeah. Just extra step. But like the top is a ton, so you want to like on the very, like you can leave this. But like work your top out so you can simplify it down some. Sometimes it's helpful to leave this though, depending on what you have, because you can cancel stuff out.
So you have one of them simplified and the other one not simplified.
Well, it's part of it. I mean, you can FOIL it out if you want, but it's messy and takes a lot of time that you don't need.
So we're gonna work out the bottom.
So we're going to work out the top.
Are we just multiplying?
So yeah, we're going to FOIL the first two. So 6x cubed plus 8x squared minus 30x squared minus 40x. And then we have to distribute this minus sign through on the side. So minus 2x cubed minus 4x squared plus 7.
If that wasn't a 1, would you do that first and then?
Yes. Yeah. So that's a good point. All right, if this isn't a 1, if you actually have to multiply something, multiply first, then subtract everything. So then you get 4x cubed minus 26x squared minus 40x plus 7 over x minus 5. Because we're subtracting it, distribute the negative through. You don't get to make vomit sounds. That's my thing.
So how we gonna do the thing we did? You can't cancel right now. I don't believe.
What do you mean? You're done.
Wouldn't that be a 28x?
No, because you have this as well. Wait,
It'd be 24.
what did I do?
Are you talking x squared?
If you're doing that, then that'd be like 24.
This would be negative 22x squared, and then minus 4x squared is negative 26x squared. I'm right.
Oh, no.
Oh,
8 minus 30
yeah.
is 22.
I missed. Is this on here?
Yes.
Is that the F on G?
Uh-huh.
Why is F in the bottom stream?
Yes.
Why'd you not carry the 2 in on the bottom?
Just like go ahead and.
I mean, you can, but if it's not gonna like serve a purpose, I wouldn't bother with it. All right, let's do number B, even though it's not a number. All right, so what's the first part? Denominator times the derivative of the top, which is e to the x, minus the top times the derivative of the bottom, all over the bottom squared.
Wait, is it the top times the derivative of these both?
Oh. Yes. Thank you. There we go.
Bless you, child.
I'm not gone. I'm just dying.
Do you put the EX before the X squared usually?
Yeah, I'm actually looking at this, interestingly enough. So, fun fact, they factored out an e to the x on top, and then just left it as x squared minus 2x plus 1. Because you have it here and here.
But then they still change that to a negative.
Huh?
Is that just what you get if you eventually multiply it over?
Yeah.
Oh, because they're both by an EX, right? And then that negative.
Yeah, you would have an e to the x in everything.
And then that 2x turns negative.
Yeah. So, it's helpful to look for stuff you have in common and simplify it that way.
Why is the E outside?
Because I factored it out. That's what we were just talking about.
Should you do X before? Wait, would that be your answer you're just saying?
I'd be happy to stop there, yeah.
I feel like I'm not going to know when to stop there, and I'll just keep going until everything is simple.
That works too. Alright. Let's do C and D and then we can call it a day, okay? Alright.
Can you help me with that?
Yeah, I will. Alright, so the bottom. Ooh, that's a highlighter.
No.
This is a fraction of a fraction, is it?
Yeah.
It is.
I just
I was right.
Oh, calm down.
That's 1 over X.
Right.
Over X times N.
Alright.
I enjoy my fractions over fractions. They bring me joy.
Sure they do. Okay, so the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Would you like to get rid of that, Isaac?
Nah.
It's really easy.
I say we just keep it.
No,
You cancel the X out, right?
no,
No?
Easy.
because it's x minus 2.
So it would be,
So we can multiply by x over x. So on top, it will cancel this one out. So then you get x minus 2 minus x ln x over x times x minus 2 squared.
Times X over X.
Yeah, because like typically you don't want to leave fractions inside of
Why
fractions.
is it X L and I? Oh,
Because I have to distribute the x to both pieces, right? So to this part, it caused this to go away. Because x times 1 over x cancels out, right? This one, it just goes in front.
why wouldn't it turn to ln x squared?
Because it's ln of x. We're just multiplying that, whatever that number is, by x. We're not taking the log of x squared, or the natural log of x squared.
I hate everything.
You know when you start coughing though, and then it's just like you're down X in your chest and you can't stop?
Yeah, it's the
you
worst.
leave it as that?
Yeah,
Why can't we make it a fraction over a fraction?
because we don't like that. Like it's not, it doesn't, like you want to simplify things.
I do.
No, you don't. You don't like solving them. That's what you don't like.
Yeah, that's right.
All right, ready for the last one? Well, we'll wait for Dylan, but when does varsity volleyball play? Like what time? So you take the bottom
This way.
times the derivative of the top. So the derivative of sine is
Son.
no cosine minus the top times the derivative of the bottom, which is negative sine. Okay, so distribute. Oh, wait. Over 1 plus cosine squared. Okay, so distribute. So you get cosine x plus cosine squared x minus sine squared x.
You ever call
Isn't
so much you
plus
feel
sign squared?
lightheaded?
Yeah. It's plus sign squared, isn't it?
Yes, thank you.
I just need a relaxing day in the office.
Would you take like a... I'm using like glue or something. But get a black-
Why is it?
Did you say I needed some breathe?
You know, breathe.
Plus
there's
cos.
nothing
Oh,
like
for
breathe actually is great when you have a stubby nose.
So is peppermint. Honestly, I just
Yeah,
like
like
roll it
the-
under
Okay,
my
but
nose.
take that out of context. Say you don't know what breathe is.
Oh,
You know,
yeah.
you need some breathe. It's like I'm trying. I
You
can't.
don't know that.
That's funny.
Go, someone's choking. You need some breathe.
Okay, so then, does anybody remember what this is? What this equals?
Tangent.
Ooh.
Oh, cosecant. Cosine. Okay.
Man, where's Emma when you need her? She has her trig identity sheet in her iPad still.
Wait,
I
that's
do.
180. Oh no.
I have mine at home. I need to bring it.
Not the unit circle.
Does it equal?
No, not my unit circle. I think.
You have a trig identity. You do!
No shot.
How does Dylan have
How does Dylan have? The
I'm sorry,
one
wait, pause. Is that from last year or did I give you one this year?
This year.
Oh.
Did I?
Why would I have one from last year? You
Dylan.
know I don't have one.
Dylan, I don't think I gave you that this year.
Did you
Dylan
actually-
just has a
Dylan actually has
Because
something.
we got rid of everything in iPad. Wait, I'm seeing if
Yeah.
I have one.
Dylan
Cosine squared. 1 beta?
1.
Dylan actually,
Cosine squared plus sine squared equals 1.
Wait.
Y'all, Dylan has
Dylan actually
something
has
from last year.
From 3 years ago or 2 years ago.
Last year.
Last year we did give him a round of applause.
If I have something from last week, you need to give me a round.
This is true. If he has his
I don't think I gave you guys one of those this year. Maybe I did.
I think
I don't have one.
Either way, the fact that Dylan has it is a miracle.
maybe just for once I'm the only one that does have something.
Yay.
No, that can't be possible.
Dylan.
Let me check. There's,
Listen here,
I'm not
Archie, don't
letting-
ruin the moment.
Just let Dylan have his moment.
I don't think we do, Dylan. No. Dylan, you actually kept that from last year. Yeah, that's all.
All right, now that we've celebrated Dylan, let's continue. Actually, I'm going to rearrange this. So cosine squared plus sine squared is 1. So now what?
We're done.
No, we're not. What do we have? What can we do?
1 squared.
No.
Cancel.
You can cancel 1.
1 over whatever.
So 1 over 1 plus cosine x.
For real, that's what I was trying to say.
Dylan still can't believe himself.
Don't narrate for me. I'll do my own narrating. Well, I've actually been keeping these this year. Everything that I have
that I own from physics or math goes by.